All right, welcome to our Hydropower Prospector presentation. This is Nicole Williams. I'm here with Jocelyn Anderson, and we are going to show you our project. So the purpose of our project was to create a standalone desktop application that would allow the user to find the hydropower capacity, the volume, and the area of the reservoir. These were our three goals. So kind of the main points that we are going to cover are how to load a DEM, how to calculate the minimum elevation, and also how to find the area and volume, put those on a chart, and finally to find the potential hydropower capacity of this reservoir of your size and choosing. So we're going to start off and we're just going to show you what it does. We're going to run our code. So this is our program. And we thought that a wizard would be the fastest and easiest way, and that it would also allow the user to kind of understand what was going on. So you just kind of follow the buttons and the instructions. First thing you do, add DM. So we're going to add that geotiff, and once it loads, then you can create a dam line. So you start with a single click, add a double click to finish, and then you can find the minimum elevation of this line. Then it will put it right down there, so you can see that it is 1,363 meters. So now we're going to digitize the polygon where we want to have our polygon cover. So I'm just going to double click to end, and this will clip the polygon with the DEM, and so that we just can analyze the area that is inside of that polygon. So there we go. So now we can choose how high we want our dam to be. Let's say we want 100 meters. So we click that button and it will calculate the storage in the area. And you can see here our fancy blue color shows the area that is going to be filled if a dam is built at that height. And then you can come down here and we have the storage capacity curve and we have the area versus elevation curve. If you click there, it will show you on the bottom axis here you have volume in cubic meters, and on the top here you have the elevation. So it shows as the dam were to fill how much capacity you have, how much volume would have, and similarly as the elevation increases, how the area increases in square kilometers. So that is the final thing that this will do is find the power that you could have from a dam at this size. So we're just going to assume 8 cubic meters per second with an efficiency of 80, and it actually will assume that the turbine is 5 meters above the base of the dam. And so as you can see, that calculation is about 6 kilowatt hours. So that is our presentation, and let's say that we decided that we wanted to change some of those things. You could basically run this whole thing all over without having to kill it, and Jocelyn is going to walk you through that.
Hi, so it is possible to go back and change everything about this, but let's just say that we want to just change the elevation of the dam. You can change the rest and it will just overwrite those files, but just for simplicity's sake, let's just say that we decide to make the dam 200 meters. So let's calculate the storage in the area. So as you can see, the new storage came up and it's a bigger blue area, and then it will show up in the legend as the reservoir at 200 meters. And then also we can look at the storage capacity curve, and it's changed to be at 200 meters, as well as the area and elevation curve. Now if we want to go to see those files later, we can go into our bin and our data, and there we have both the area and stored at 100 meters and 200 meters, same as the reservoir shape files, and also the storage is also saved at those two, and it would do it for additional levels if we were to do those as well. And then same as before, we can change the flow. We're going to go 25 CMS and a super impossible efficiency of 99%, and we're going to calculate that hydropower and get 47 kilowatts. So then that's the very end and a progress bar is full and you've got your results saved for later. So let's go through the code now and we'll hand it off to Nicole.
All right, so you start off with some basic housekeeping things, loading systems, defining variables, points, lists, booleans, you name it. So then we come down here to the menu list. Those are all of the menu items that we need, and this is the code that allows our wizard to function. As you can see, we have the progress bar code here that will add or subtract 20% as you move from tab to tab. So here's kind of where our coding begins, the processing begins. You start off by adding the DEM layer. We did the try catch just in case some kind of error happened so that it wouldn't throw up an error message. Here is, if you click the button to start digitizing, it tells the code that it's digitizing by setting this boolean as true. And then since that boolean is true, when you click on the mouse, it knows to run this code. And it will basically just add the coordinates of the point that you click to this list. And this invalidate code is what allows you to see the lines as you are digitizing. It basically just means that everything on the map is invalid and you have to redraw it. So it will redraw and you can see those lines. And then the same thing happens for the polygons. Very similar code, just with a polygon instead of a line. And so same thing, these next two functions allow you to see the lines and the dotted lines as you move. So as you move your mouse, it will again invalidate it so that you can see the dotted lines, and this paint function allows you to add all of the fancy coloring and lines as you are drawing for both the polygon and the line. So the double click, when you double click, it saves the last point that you double clicked to this list, and then it will tell the code that it is no longer digitizing, save, and refresh. So same thing happens with the polygon. And then you move on to finding the elevation at that line. So basically what we did here is we divided this into 100 equal intervals. And so what will happen is the code will step along this line at each one of those intervals, and it will check the elevation. And so if that elevation at that new step along the line is smaller than the last recorded one, it will save it. So basically what happens is you will end up finding right here the minimum of all of those 100 points checked, and then you can add that to the list, and you can report that on the interface so that you can see what the minimum elevation is. And so now Jocelyn is going to take you through the rest of our code. This is where the main calculation happens.
So we then cut out the DEM just where the polygon is, and that's what this goes through and does, and it finds that if it intersects then it keeps it, otherwise it gives it a no data value. And so then we save that so that we can use it in this next part, which this is the big calculations function. What it does is it takes the polygon DEM from the legend and then it makes a blank DEM, and the blank DEM is given an elevation of the dam height plus that minimum elevation that we found earlier. And so those two are subtracted, and if they are positive, they are given that value, and if they're negative, then they're given a no data value. And that's saved in here in the reservoir with the elevation height so that it can be found later. And then it's given a blue color schemes, and that gives the raster for where the reservoir is filled. And so then we calculate the volume in the area. We find the minimum elevation at the reservoir and the maximum elevation of the reservoir. And then we break it up into 50 segments, and we step through all of those intervals, and we populate these arrays that we create right here. And how we do that is we go through, and if it's between 0 and that elevation, the minimum elevation plus whatever interval we're at times that interval size that we're taking, if it's in between those values, then it adds the number of cells together, and it also adds on that elevation so that later we can populate the elevation values, the volume values, and the area values based on each interval, which then goes in to make the graph. And then these graphs are then stored as XML so that they can be looked at later, also referring to the elevation text so that the user can find them. And then finally, the hydropower calculation, we just have the hydropower being the head times the efficiency divided by 100 since it's a percentage times gravity times the flow and divided by 1000 so that we can get it into kilowatts. And that is our code. Thank you very much for listening, and we hope that you enjoyed.